February session. This is the first of the year, the first session for the year. We didn't do any in January. It was too close to, was too close to the new year, and I was really needing a break. So today we have another interesting session from a speaker that we have enjoyed and learned from last year. So he's been gracious to come have another session with us this February and also next month. I'll share about the next month's one. So the agenda is we're currently in the introduction. I'll try to speed through this so that I stop even if possible before 8:05. And the topic is implementing Medallion architecture with Microsoft Fabric. At the end, we would have Q&A. And if the presenter, if you have so many questions and the presenter is willing to stay and answer your questions, then you might be lucky that the Q&A extends beyond this time here. And our presenter is Alexander Tolov. He's a professional consultant. He specializes in cloud data architecture. He's got decades of experience in this space.
Very good.
And so it's always a pleasure to always have him. He's a certified Microsoft Fabric data engineer. He's someone who enjoys contributing in the community. I met him at a session at Microsoft Office, and I approached him, and he's always been willing to always have sessions for us and share his wealth of knowledge with us. I'm going to share his LinkedIn link so you can connect with him. And that's it from me. I'm going to stop sharing my screen and hand over to him and also turn off my camera so I don't distract. And so, Alexander, over to you.
All right. Thank you, Michael. This is always a good time for me when I have a chance to speak with all you guys. I'm saying hello to everyone. I don't know exactly what time of the day you are coming from. It's evening in Toronto here. I will turn off my camera right now, so it's not a distraction for you. But when we switch to the Q&A session, I will turn it on again so you can see my face when I'm answering the questions. Just to encourage you, don't be passive. Questions are absolutely a good thing. I will enjoy answering all of your questions, whatever you have in regards to this presentation. Now, jumping into the session, right? Today we're talking about one of the most important design patterns in data platforms, in data engineering. It's known as a medallion architecture. And not just the Medallion architecture, but why Microsoft Fabric, which is one of the newest and most fastest growing data platform in the industry, is a very good fit and makes it a great platform for implementing the Medallion architecture. By the end of this session, I aim for you to understand why Medallion architecture exists, why it's important, how it fits the Microsoft Fabric. And we will do a live session with the walkthrough. So you will see firsthand how it can be implemented, and you will have something to take home with you. A little bit about myself. At this point, well, Michael already introduced me. This is just a formal slide. There's nothing here that's important. I'm a consultant. The only one thing that is important for you when you listen to me is to understand that I understand what I'm talking about. I've been working with Fabric for several years now, almost since it was introduced in GA. And I acquired a lot of practical hands-on experience that I'm very eager to share with all you. And thanks for coming and listening to this. Now, today goals, I kind of shortly already announced, but let's just go through. Like number one, we want to understand the why. What Medallion, that Medallion architecture, it's not just a naming convention. It's actually a mindset, and it's a quality contract. between the different layers. And the layers will learn. Now, second is to see the how, because we want to not only understand how Medallion architecture works in principle, but also see how it works in Microsoft Fabric. And the third most important goal is that you get to see how it can be really implemented hands-on, and you will get to take this presentation as a blueprint for your potential future work with Microsoft Fabric. Let's call it the runbook, if you wish. Now let's just talk a little bit here about the history. Why the data lakes? Now, well, roughly about 10 years ago, the cloud platforms made storage really cheap and expensive. If we're talking about the Azure, we already had the product called Azure Data Lake. At that time, it was Gen 1. Now, it was so cheap that it was practically a nonsense to spend time discussing how much data we want to throw in it. So every data lake became a basket of stuff. And when that happened, what also happened is the second effect, which we now know to call a data swamp problem. So the reason for that was that so many people used that data lake being a huge unlimited storage practically with no material cost, that there was absolutely no idea of how to organize that. It was just a file system. And that created a problem of multiple data copies with slightly different structures. And the most important problem that I call missing single source of truth. And as a result of this, people started thinking. Now, at some point, the Medallion was introduced as a solution for that. What if, instead of having so many different similar copies of data with slightly modified structures and processes and whatnot, we create the layers, and we make sure that data can only traverse between the layers in one direction, and only along this road we will make changes that will be available to everyone. So that's actually a medallion. And it's not a magic by all means. It's just a discipline. It's a state of mind, and you can practice and train to use it and think in terms of the medallion, and you will learn that it absolutely works. Now, the key of the medallion is the layering model. I know it's not a good joke in terms of here, but when it's cold, we're layers, and we know about those layers, and we use the concept of layers all the time. And actually, the very first layer that we know about the medallions called the raw layer or the bronze layer. We can call it as it is, but it's a landing zone, meaning that that's what the data swamp started from when everybody was throwing their data on it. Now we keep doing this, but we have a limited space for that, not limited in size, but limited in purpose. We only store there the original data. What that means is that no transformations, no deletions, however data was present at the original source, that's exactly how we store it. So essentially, it's a read-only archive of data. Why do we want, and we have a bronze color assigned to it, right? Now, the next layer is we call silver or enriched. And this is what happens with data after we execute the cleaning and we made it conformed to known schemas, and we validate all the missing parts of this data. So we make sure that it has a usable presentation. And this is the layer, this is the very first layer that we can start querying, and we call it the single version of truth. Now, it's an interesting detail because we don't call the single source of truth the next layer, which we know is gold. Essentially, we're calling the single source of truth is the silver layer because gold is built on top of the silver layer, and we use it for reporting, for summaries, for different KPIs, for dashboards. And this is the working layer. And the another name that you may have heard before, it's a data product. But essentially, it's not the original truth. The silver layer is your original source, and the gold is the derivative, and the bronze is the original. Now, why does it matter? Well, let me tell you a story. Well, you've heard it probably, and I've personally seen it many, many times. Now, one team works on acquiring data, and they land them into your data lake, and another team cleans it, and then another team uses it to build in the report. And then what happens is that the data that the first team lands changes, like in structure. And all three teams are immediately affected. And all the data that have been derived from the original data sources, it doesn't make any sense anymore. So we want to change that. Now, when we have the medallion, what we actually have is we have, instead of a mess on our data lake, we have an order, because we clearly separate three different layers of data. We have absolutely the clearest possible way of understanding the data. We have the contracts, we have the resilience. Even if anything changes in our bronze layer, it does not immediately affect everything downstream from here. We can apply reusability, we can apply patterns, but most importantly, what we have is the lineage. And lineage is the word that may not be very often used in the data practitioners' dialogues, but you may have heard about it in terms of family trees, right? So we want to know where we come from, but being data professionals, we absolutely want to know where the data come from because of that constantly raised question of where is the truth, right? So that's the why layers matter, and that's why we want to use them to organize our data to the specific order. Now, about the Microsoft Fabric. Why it's a good environment? Why is it a good platform to implement the Medallion architecture? Well, first of all, Fabric is specifically built for Medallion. It has a built-in unified data storage. We know it as one lake. Now, you might think of it as the same way as about the data swamp on any other data storage, but it's actually not, because there's no direct way to use it as a file system. Instead, what we have the lake houses. Lake house, it's your storage on top of the data lake that allows you to create a boundary around your data and organize your data into specific layers. We can have, for each layer, we can have a lake house. Now, lake house on one lake, it provides both tabular formats for tables and unstructured file system for files. The underlying data structure everywhere in Fabric is unified, and it's called a delta format. everything, each and every workload, each and every data storage type that exists in Fabric uses the Delta format underneath the scene. The next is on top of that, once we have the data, we need an engine to query it. Now, Fabric comes with multitude of different engines, specifically the ones that we will be using today, and they're most widely used across the Fabric are SQL engine, the Spark engine, and the Power BI engine. The principle that is laid around this engine is very simple. You don't need to create a duplicate copy of data to use another engine. All engines can work directly against the same set of data, and you can query it with all the engines without any need to duplicate anything. The most important thing here is this. So ETL is not required for you to move between the engines. And finally, there is a governance, right? Which is extremely important when we want to have the order. And what's important about the Fabric is that the governance built in. There's no need to create anything and put it on top of your data. The automatic data lineage tracking is native and it's built in from the very beginning. On top of that, we have very detailed role-based access control that allows to manage access to each and every individual piece of data in each and every layer. If it's not enough, I can assure you that the Fabric comes with the secret sauces. Well, or I may call them that. Now, one of them is known as a shortcut, and these features are very unique to Fabric because, well, at least I didn't hear that any other platforms would use a similar technique with the similar name. Now, shortcuts allow you to create a virtual link. It's a data virtualization technique. It allows to bring data into Fabric from both internal and external data set without direct physical copying. Now, I can tell that there is no magic behind it. So if the data moves, it has to be copied, but you just don't do it. Fabric does it to you as a platform. And the most important that it's a zero ETL. What that means is that you don't need to implement any working system to realize that. And we will see that in life. Second ingredient of the Fabric secret sauce is what's called materialized lake views or MLVs. What that is essentially is if you've been working with data and specifically SQL databases long enough, you know that there are views that are declarative SQL-based syntax that allows you to define the different data presentation layer on top of the original data layer. Now, word materialized here only means one thing, is that when the views executes in Fabric, it creates a new, completely separate set of data that was built to the specification of this declarative definition. And that's what allows us to create in a very easy way, without any additional particular efforts, the layers, the silver and the gold. Now, the MLVs, they're not just the way to create the presentation on top of the original data, because they provide quite a complicated syntax that allows you to implement cleanup checks, constraints, transformations right in that query, which will, all of that will be executed during the data refresh. And all that presents to you a zero effort ETL that is built right into the Fabric and comes with the built-in lineage tracking and incremental load support. And the outcome of this, well, everybody's happy. We have what we want. We can segregate our data in layers, and we can get the result, and we know exactly where the source of truth is. That's the goal. Now, before we go to our live demo, let's just talk about what we how this all fits together, right? So this is relatively simple. On the left side, as you see, we have all kinds of data sources. They can be internal, external, they can be of different types, they can be structured, not structured, coming from third parties, coming from your own data sources, both on premises and in cloud. Now we have put them, we collected all this information using the shortcuts, and we saved them in our bronze layer lakehouse. We can apply partitioning. We can make sure that this data is in exactly the same form and shape as it was in the original. So we create the archive. Now, the next step, of course, we execute the transformation. We can use different tools. I will be showing you how to use the MLVs, but obviously we're not limited to MLVs. We can use notebooks that will run in Spark Engine. We can use data flows that will run in M Engine that is behind the Power BI. We can use pipelines that will allow us to orchestrate different kinds of operations here and there. And finally, when it comes to the gold, and we transformed the silver data into dimensional models, which can be many. Gold doesn't have to be a single layer. I mean, the layer is the same, but the data sets can be many. They are all derived from the same single source of truth in silver, and they can only all be used to create the external reports or query them directly, and essentially that's a consumer layer. That's about the reference architecture, and what we can do next at this point is it's time for our demo. So we want to switch over to Fabric and do stuff in Fabric for the next about 20-25 minutes. And I will switch the screens for this. But before we do this, I just want to let you know what's going to happen in Fabric, right? So this is how our data set that we will be working with looks. And this is the model that we will be implementing. Now, there's a little bit of time limitation for our presentation. So I won't be able to use all full scale techniques to show you live. So I will use the CSV files that are specifically prepared, for fast consumption, and we're simulating, the infamous or famous Contoso retail sales company. We will be dealing with the orders, sales, locations, agents, and additional information in the bronze layer. Now, we will be using just one single lakehouse for simplicity, but I will show you that that's not a limitation in this scenario. Because lakehouse are schema enabled, and we will be using schemas for layers. We will be using the zero ETL with shortcuts for ingestion of our bronze, of our raw data into the bronze, and we will be using the MLVs for transformation exactly how I announced it. We will have a little bit of the silver data that we will mostly use for cleanup. And so it's not direct, it's not 100% a dimensional schema, it's a simplified thing, but for our demo purpose, that's totally valid. And what we will observe is that all layers are there, visible, populated with data, accessible. We can look at the lineage of how data travels from left to right, from the origin to the destination. And we will see that the zero ETL approach actually works. And that's our demo time. At this point, let me just switch the screens because I want to go to my Fabric environment and show you what is going on here. Right. Okay. Michael, can you confirm that we're looking at the Fabric screen at this
Yes,
point?
correct. Medallion demo.
Right. Perfect. All right. So for those of you, I don't know, guys, do you want to do a show of hands and just raise your hand, whoever has experience working with Fabric, because I didn't have in my mind to do any introduction to what Fabric is. Yeah, I see one hand. Do I see more? There's a button, you can click there, show your hand. Don't be shy. If you've heard about it, about Fabric, if you've read about it, if you tried it, that's okay. All right, let's just move on. This is all good. Now, remember what we've been working with. And this is what's called in Fabric a workspace. Everything in Fabric belongs to a workspace. Essentially, it's your security boundary. This is where you keep your artifacts that you create in Fabric. Most importantly, you also can integrate it with the source control, Azure DevOps, or GitHub. And this way, you see in my scenario, it's integrated. So I have stuff synced and copied. So if by any chance you remove anything here, you can always restore it from the Git. That's just a very quick introduction. Now you see we have elements here. The very first one, it's our data. And we have the sales lake house that is created, the one that I want to open. And as I promised to you, all sales lake houses, they come in Fabric with support for tables and support for files. Now we start from our raw data. And we will see that I have uploaded in here files. Now it's really easy to work with the file. It looks like a normal file server. So if I wanted to do anything here, I can say new subfolder and it will be created here. So in my situation, I have different file sources and I created a subfolder for each specific file source that represents a single entity in my business model, and I want to make that entity a table. So I created the folder structure here. Next step, what I did, I said, I want to upload a file, right? So, and I can do that easily by just picking a file from my local file system and upload it. Now, before I do any of this, I already, to save us time, I already pre-uploaded some things, and I can show you, I have the CSV files in different folders. You can see them. And if we want to even look inside, we can. We can just click on any of these files and we will see the preview. And you see that this is a CSV file with the first row being a header that defines our columns. That's how the file system works in Lakehouse. So I already have my raw data here. It's dumped here, right? Now, the next step that I want to do is I want to make sure that I load that. So this is our very first part of our exercise. We want to load data into our tables. Now, you see, I defined the schema, right? How did I do this? It's really easy. I can say new schema and I can enter the name and it will appear here. And the schema is exactly the same. Here is exactly the same as if it was a normal relational database in SQL Server or Postgres or any other database, SQL database. We will be using Bronze. Now, for us to use Bronze, and load the data, what we want to do is we want to use the shortcut. What that means is, let me just expand that schema, and I'll show you. So let's do this. It's already preloaded, but I will delete that thing for you, and I will show you how the shortcut actually works. Now we can just take a look and say, look, this is the result of how the shortcut works, and it's doing the table show, and you see that there is a table that is created here, right? And we can see the data is there. If I look at the agent folder, remember I had these two CSV files. The content of these files is right here in this table. However, I just deleted the agent commission, so we only have 4 tables here. I'll refresh it just for the sake of being actual. And I want to do loading of agent commission created as a table. What I do is I go to my schema and I say new table shortcut. And I choose the one lake source. In my case, I have sales lake house that belongs to our Medallion demo workspace. That's the one I know where I stored my raw data in the file system. And this is the file system. And you see that structure, it's exactly the same structure. Now, I already loaded others. Now I want to pick this one. So I select that. I can verify if I have files. I have a CSV file in there. I select this. And here comes the magic, right? See what happens here is the magic wand says auto transform applied. What kind of transformation? From CSV to Delta. What happens essentially, we create a virtual pipeline that will read the data from the CSV file, and it will load the data. It will create the Delta table in our lakehouse with this exact name that we selected, agent commissions, and it will load the data from the CSV files right into this table. Let's do this. So all configured, I click create, and I have time reserved for this operation. It takes a minute. Essentially, it may take longer. It depends on how much data we are working with. In this particular situation, you see it's still working here. And the only way for me to verify is whether it's moved or not. I need to refresh that. And there you go. Now, what exactly happened behind the scene? We can learn if we click on Manage Shortcut. And you can see that it's an interesting icon here, right? Because you see there's a triangle. Now we have notification that was completed, but we already knew that. The triangle represents the Delta format. Now the link, a little link icon right here. Let me try and see. Yes, I can bring this. I can make it larger, and you can see that there is a link which is a Delta table shortcut. That's exactly what we have created there. All right. Now, if I want to see how that whole situation works, I click on Manage Shortcut, and what I see is I see the history of the situation. Now that the shortcut exists, it's an active pipeline. What it does, it monitors that target file subpath for any new data incoming. And if any new data was found, it would append them to this Delta table. And it will convert from the CSV format to the Delta format. And we will see it later. Now, here you see it only took 21 seconds. Now, remember we talked about the fact that once we have the data in here, we can query it right away. We can query that raw data that sits in bronze at this point. How we do this, what we want to do is we want to switch to the SQL analytical endpoint every lakehouse is equipped with. I already have it open here. I don't need to open it 2 times. And you can see that initially I had just 4 tables, but let me refresh that. So we should be able to see that there's that thing. Now, just for our own sake, see, I have the select 100, right, from this table. We just run it, and this is a SQL. And you see we have it, right? Notice one thing, that we have a column that does not exist in the original raw data in our CSV files. This is a column that was added by the automatic Delta transformation. It's called underscore file path, and it points to the original source of the file. Now, just because we load it from one single file, what I expect to see is that if I query just the distinct value in this column, I should be able to see only one value, right? That's exactly what I expected. Perfect. All right. Now, we're done with the with the bronze layer, and we want to switch to silver. Let me show you that I already have stuff in here. If you remember that slide that we had here, right? That was our data scheme that we claim that we will be working with. Okay, so that's exactly how it looks here. Essentially, you see that there are two delta tables. However, they have a different icon. Let me bring it up a little bit so you see it, right? This icon represents the MLV, which is materialized lake view. And this icon actually says that this is the active thing. It's also a working pipeline, also working behind the scene. And I can show you that there's data in there right away. Now we need to learn how it was actually put in there. For that, what we have in our workspace, we have a notebook. And that notebook is called Silver Gold because it creates the materialized lake views in both silver and gold layers. And let's just take a quick look. Now, if you don't mind, guys, again, just give me a show of hands, quick one. Who is familiar with the notebooks and understand what they do? Just even briefly on the very low level. No need to be an expert in this. I just want to place my uh, uh, sort of understanding of, yep, I see hands. Great, nice. I love it. Great team tonight. Michael, you can be proud. We have a great team. We're looking at a great topic. All right.
Thank you.
So, so we have the cells, right? And the cells, what they do is that they create schema if not exist. Right. Specifically, I want to create the silver schema, and later downstream, we want to create the gold schema. Right now, as I said, because this is a fully declarative way of defining stuff, uh, it's a SQL. But you see, it's not a T-SQL, right? Because it's a Spark SQL, because the notebook is executed by the Spark engine. But this command creates, let's focus, right? It creates sales consolidated MLV. That's one. And you see what it does. It takes the orders table from the bronze layer, right? And then it joins it with other two sources in the bronze layer from sales and locations using the match on the key cones, right? That's one thing. And the result of it is that it was created because I already ran it for you before. The second one for here, it's also created exactly the same way. And it's the sales data clean. What it does, it introduces a constraint which says, look, we don't want any records where the customer ID is null, because that would be either a fake or a completely unusable record for our single source of truth. So we don't want that. We don't do anything more sophisticated, but we can. Absolutely. If later we have time, I have some examples of how sophisticated dimensional modeling with the materialized lake views can be. If we have time, we'll look at it. Now, I won't touch that. And you remember, if I show you that thing, right? If you look at the very bottom of this diagram where we have the agent and agent commissions, they go directly to the gold layer because they are joined into total commissions gold table that doesn't apparently require any silver cleaning. This is not the proper way of doing stuff, but for our demo, it's okay. Don't hold me for that under your targets. So we have exactly the same approach. We create schema if it doesn't exist and for the gold layer. Let me expand that. And you will see that we have tables here already created. Let me just refresh that. And what we will do essentially, I will just do this. I will delete our total commission tables. Why? Because we deleted the agent commission tables in the raw, right? And then we reintroduced it. So I want to make sure that I recreate it again from scratch, so we're not missing any data. Now, I don't need to create the schema. I don't need to create order priority. It's already here. I don't need sales ship mode. I don't need sales products. I only need to create the total commission. That's the one that I will run. Right? So I just click run cell, and we will observe how that whole thing is working. You see down here below, we're starting the session, which is a Spark session, and now we're running, and we're running that cell. I should have cleaned the output here. We will see when it finishes. See, the date here is my bad. You know what? I want to stop that because this is the wrong cell. I needed to start from this one. I cannot create the fact sales. I should have removed that one as well. Do that. We'll make sure that there is nothing here that we don't want. Okay, so we will start from here. Let me clear the output because we don't want to see the previously executed tasks. And we will start it again, but we will start from total commission, then we'll create the fact sales because total commission is part of the fact sales. So we start from here. We're starting the session again. And then the session started. Now we're running that cell. It will take a little bit of time because of processing. We will see here very soon that Spark decided that it only needed this number of jobs and it's running them. And you're having the taste of real-time execution in this particular situation for joining two different tables and creating the MLV, right? And the next, we want to run this one. And we can examine the result from our operations. You see that we have the full refresh. We can talk about it later if we have time, because MLVs fully support incremental refresh instead of the full, but the very first load always goes with the full refresh. Now we need to wait for the final thing to finish, and then we will update. We will see that we have full set of tables for our experiment, and even more. Done? Yep, this one was much faster. Let me just refresh here what we have, and you see that we have two new tables. I will switch back to my lakehouse to show you what's going on in here and the gold layer. Let me just refresh that. We have that. Let's click quickly here just to see if we were successful with loading our data. When we're working with the lakehouse, most of the times we're using the Spark engine behind the scene for doing any jobs. That's why we see this kind of things. While it's running, I can switch to my, it shows no records, which is wrong. But let's just switch to the SQL endpoint and switch to our gold layer right here, and we will refresh SQL endpoint. We will look at the gold layer and we will see the tables here. Total commission, we can execute the SQL query. Ah, 0 rows. That's unexpected, honestly, but we'll deal with it in the next step. I promise you that we will not lose this information. However, if we look at the Fox sales, which we want to do at this point because that's important for us, the same stuff, right? What we can do is we can do this. So that would be normal because we don't really need to load the data when we create the materialized lake views. Instead, what we can do is we can switch in the materialized lake views to our lineage. That's exactly how we manage data. And lineage means that we can see how different data sources progress through iterations and where they end up, right? Now, for example, we've been loading this information and you see that it affects the gold total commission and it affects gold fact sales. That may be the reason why we're not seeing any data, but that's absolutely no issue because what I can do is click run. And what that means, it's a refresh. So at this point, what we want the system to do is we want it to look into the data sources and identify if there were any new data available or not, and update our materialized lake views so we can take a look at some data. How can we monitor that? Because again, this is a Spark job, right? And you see, if I switch here, it's running here, but it's interesting to see that on directly on our lineage. See, because of the dependencies, what happens here is that these tables, these materials lake views in gold layer, they cannot be updated before the data that they depend on is updated, right? So the very first layer that we're updating is this one, right? That's the one that is running the progress. It's called silver sales consolidated. Once that one finished, the next one can start. And eventually we will progress through this layer and go to our gold model. And we will let it run, okay? We don't need to monitor it. We can refresh time to time. We see that the consolidated completed next one is in progress. We'll come back here and we will look at it. Meanwhile, what we can do is we can progress with our implementation of the gold layer, which requires for us to have what? It requires to have a way to look at the data in the reporting view, right? Now for that, what I want to do is I want to click on the button and create a new semantic model because this is the foundation for our report. I already created one for you. It's right here. Sorry, it's right here. I only added the gold layer here in this model. Now, one thing that I didn't do that I want to show you, in case you're not familiar, is that this is actually the semantic model editor. So I don't really need to use any desktop tools. I can do this right in Fabric, and I can open my semantic model from my workspace right here, and I can open it for editing and switch into the edit mode. And there's one thing that I'm missing in my semantic model, specifically for the table total commission. I have no relations which I want to add. And I know that the agent ID should be related to the agent ID in the sales data table. So that's what I do. I just introduce that relationship by doing this manual iteration drag and drop, and I click save. And that should be totally enough for us for this model to be usable. And we will try and use it in the very soon. Meanwhile, let's just go to our materialized view refresh and see what is going on. See, refresh claims it was completed. So technically, we should expect all the data to flow up to here, right? Let's just verify that. Let's go here. I'm using the SQL endpoint to just show you that the SQL engine can be used against our lakehouse. And I refresh the entire thing. So I start from the customer data, and I will see that, yes, I have some data. I'll go to, for example, sales products, and do exactly the same, and I have data. And then I go to our total commission. And I still don't have data. I cannot explain it to you, but I will try and fix it very soon by doing very simple iteration, the one that I promise you to show, which is how the automated ingestion works. You remember what happens here with the agent commission. We had that file, and I want, let me just check that we have it here, right? So it's there. Refresh. I want to check that we have previously loaded this data into here, and we have seen that data here. We can just click on it and we can see that it's there, right? But also you remember that we check that for that data, we only had one. We have it right here, right? So I wanted to see that select, not total commission, right? So we're looking at the bronze, my bad. So here I want to see what's going on in the file path. We have only one. Okay, so we're going back. And what I'm going to do, I'm going to go into my folder and I'm going to say that I want to add new data and upload a new file. Can I do this? Absolutely. Okay, I have another file available. None. So we have that file in our raw data. And what I expect to see is that because this is the automated pipeline, I expect to see that it's supposed to pick up that file and add it to our table. Now let's check. I want to say refresh. Now what? Something is not working for me here because I didn't pick it up. And I will try to do some tricks here and see if I can make sure that it works. Otherwise, it will be not entirely as I promised to show. Oh, yeah, it's picking it up. It shouldn't take very long, but it succeeded. Now, technically, what happened here is what it says. That was the operation, one leg transform with the status success. And what it did, it picked up a new file, and you can recognize that 1244 right here in the name. That's the file that I uploaded. Right now, how we can verify it is we can go right here, back here, and we can refresh our tables in the bronze. Why I need to refresh the tables in the SQL endpoint? Because SQL endpoint is totally separate analytics store that runs virtually on top of the lakehouse, and for it to properly execute SQL against the data, it needs to know the data was updated. Without further ado, let's just see we have more data in here. And if I went to my materialized lake views here, you know what I want to do, right? So I want to run the refresh, and I will let it run. Meanwhile, what we will do is we will switch back to our workspace because we know that it takes time. And we will do one other magic trick by Fabric. And you remember we created our semantic model. Now, what I want to do, I want to have a report. And I can create report manually, but I want to auto-create report because I am so lazy. I can pre-select data, but I will let that whole system to do its trick. And this is the data that it picked up, and it used the sales product, a couple of the columns in there for true Power BI experts like Michael, and I'm pretty sure a lot in our audience today. This is absolutely the zero level of doing nothing, but that's just the thing that Fabric can help us with. Now, let's check what's happening with, I don't care for that report, to be honest. I just want to see what's going on with our refresh. And that's it. So it keeps running. So we will wait until it completes, and we will take a look at this. At this point, essentially, my demo is done. And what I want to do is I want to switch. I want to turn on my face, and I want to switch to the Q&A because we can just go ahead and start talking about what happened today.
Let me know when to read the questions. We've got like a few, but go ahead. Just wanted to let you know.
Right, right. I just want to summarize for everyone that these key takeaways that I think it's important to take home with you all. Now, Medallion is a quality contract. What that means is that we create the data sets that are defined in our transformations, that are defined declaratively, and that can be totally separately processed and queries independently from each other. Then we have the medallion that works. Like, what does it mean? Like, if you just, create it manually one time, that's not the result that we're actually looking for. We want this work in sync and play good music for us as a great orchestra, or as I have on this icon, the uh, uh, team that runs a boat. This requires a complete synchronization of each and every layer. And I may have had some hiccups during this demo today, but essentially what happened is as soon next time I bring new data and drop it into my raw folder, it will be picked up by my shortcut transformation, and it will be converted and added to the table, after which I can trigger my MLV refresh automatically. I don't need to do it manually. I only do it manually for today's demo. And the last one is that when we work on it, we don't need to start from a huge task ahead of us. We just start small. We can start from one single table, and this is very scalable. And we can keep growing, knowing that it works for one table, then it will continue to work for any number of data sources and data destinations that we may have in mind. I think that's all I wanted to say, and we can switch to questions. I can also switch and check what's going on in Fabric. It's done here. I'm just curious because if it still didn't update the data, I will need to figure out what was wrong, because I did it so many times while preparing for this demo. It always worked for me, delete it and recreate it multiple times. So this is totally an unexpected outcome, but everything can happen. We live in the real world. So let me switch to my sales lakehouse, and I know I've been looking uh, at the gold layer, and I want to see, to be honest, I want to see the sales facts. I don't care much less for the total commission, but the fact sales, I want to see by all means. This is important. Product, customer, agent commission. No, I want to see fact sales. I want to refresh that first, so I'm dealing with the latest updated lakehouse. Now, something didn't work. All right. Well, sorry about that. What happens? It happens occasionally. I will figure it out later. And meanwhile, we can just work on our questions. Michael?
Yes, thank you. Great. And to everyone who, you've been enjoying today's session, I have posted a link for next month's session where Alexandra is talking about another important data engineering topic and something way more new. So let's start with the questions in the order in which they have come. Mexa Tech let me also come on camera. So Mexatech, you asked, this was while you were presenting the slides part, at the beginning. So he
Mm-hmm.
asked that for the ingestion, for the bronze layer, is it okay to add ingestion timestamp and file source name when loading in bronze? That's his question.
It's totally fine. Well, one thing that you've seen, that the transformation, the automatic transformation here added the file path. it didn't add the timestamp automatically. And unfortunately for us, this kind of transformation at this point has limitation. It's work in progress. Let's switch back to Fabric. So it's work in progress. It doesn't have any particular way of customizing if we want to have any columns added or not to it. I can show you again that if I create the new table shortcut here from just from the files, just for the sake of it, I'll give it a different name. I cannot give it a different name because I created from the folder, so it inherits the folder name. But if I do it for a single file, that's okay. I can do the same for the single file. But I want to show you that you cannot really customize and add additional stuff. So in our case, if we want to add the timestamp, we have, in this particular scenario, we have only sorry, do we have that? Right. No, we if we look at the original source, it doesn't come with the timestamp, right? So the only thing that we have is we have the time of processing. So technically speaking, all these rows would come from with exactly the same timestamp when we loaded them using our transformation, the one that we can see here. So it's considered not enough information, but you see we have this start time and we have completion time. So my suggestion would be, if we want to keep using the transformation, automatic transformation, is not to bother with the timestamp in the raw and bronze layer, but add that to the silver layer, because silver layer is the source of truth that you will be working with downstream. If we still need it in the raw, we can do it using different tools like pipeline. Did I answer? Michael, you're on mute.
Thank you for mentioning. Yeah, you signal that yes, they've signaled that yes. And I like the fact that you also pointed out that, the name of the file also shows up in the automatic transformation one. So
That's
if I,
that's the only thing that they add at this point. They
yeah,
add if we open, right? So you will see that this
it's
is the column that was added by the transformation itself. It was
oh,
never in the original data source.
great. So
But
imagine if
what we assume, right? So what we assume is, because it came from a single file. So if you keep dropping files in here on some kind of schedule every day or even more often, right? So you will have the timestamp inside the file path. If you
exactly,
incorporate it, yeah, exactly, right.
I was gonna say that, that becomes available for us, right, in the
And
silver
it's
to extract.
exactly right here. You can see that we have the date, and we have some additional number here that may represent the time.
Uh, Not too bad, even if it's requiring some hack with the automated one. So I wanted to just say, we could try that out. I'll go to the next question.
Yep.
So the next question is the person's name is Harhai. So this came up while you were doing the demo, actually. So their question is, could you explain why you chose to create materialized lake view in silver/gold instead of simple tables?
Well, I may not understand exactly what the simple tables mean here. right? But there is a very simple reason. Materialized lake views don't require any ETL work. Like I can create here instead of like in Silver Layer, I can just say, hey, I want a new table, right? I cannot create it from the UI. I need to run the Spark SQL to create a table, but I can do this similarly how it's done here. Instead of creating materialized lake view, I can just create a table with the schema as much as I can, but it will be just a table without any logic. What that means is for me to put the data into this table, I will need to run additional logic somewhere, a pipeline or a data flow that will load this table with data. Materialized lake views come with the automatic data loading. The only thing that I need to do is to refresh, nothing else. And it's a single command. I just say refresh materialized lake view by name. So zero
Great,
ETL. Zero ETL is the primary reason. So I want to save on my work. I want to focus on data.
great. Thank you. And all right, I hope that clarifies, the insight you are looking to get. So I'll move to the next question. So it's by Abdullah, and the question is, how does data auto update slash refresh from the materialized lake view? And I think you kind of said it now, but
Well, materialized lake views, if you see, they come with the tool that you can run automatically from here, and that specific tool will refresh the entire lineage tree, right? Well, something doesn't work in terms of this table, and for that reason specifically, that thing doesn't work here. I need to investigate because I don't really understand the reason for that, but definitely there's some hiccup with the schema because I deleted it and recreated it. Maybe the order affected how this lineage works at this point. But essentially that's the only thing that's needed. What I do, I create a notebook with the cell, with the code that executes the Spark SQL, and it executes the refresh. I have a sample of such code in a different workspace. It looks like this. It's very simple, right? So what refresh does, it updates the data in all the materialized lake views. So how materialized lake views is defined, it's similar to the SQL query as we have seen it, right? So it's a select from the source. Now, in this case, that was the gold, but for the silver, it was the bronze, right? So it selects from the bronze. Now, if the bronze changed when I run the refresh, it will pick up the new data from the bronze and it will materialize it by writing it to that built table. It's a totally standalone separate data set that exists in its own location on one lake. We can see the, if we want to, we can see the table structure. Right here, I have table view, but I can see the file view. So you can see that it's absolutely totally separate uh, file set, data set, which is already partitioned by the file path. Now, if I look inside, we'll see that there is the parquet file inside here, the same way as here. So each and every partition was loaded at its own time moment, and the refresh picks it up from here.
awesome. And let's see. A few people have asked for the when the well, one person has asked for when the recording will be uploaded. I've answered that, so I don't have to read that to you. I also put in the chat to everyone, if you've not registered for next month's session, you can RSVP. Then we have one last question from BK. So the question is, when we have a large file source in external data location, does shortcut work efficiently? How does the SCD, I think that should stand for
Slow changing
slow
dimension.
changing the type dimension. How does the SCD type implementation work? I guess that's what they mean.
Right. Well, there are actually two questions on this question, right? First one is that if the large file source work, they do, you can drop there if you have a file of, let's say, 100 megs. They actually work better because of the specifics of Delta table format. Delta table doesn't like performance-wise the small tables. It likes much better the large tables, right? 100 megabytes, that's the right size that you can drop in here, and it will happily pick it up and load it into the table. Now, it will not take seconds, of course, it will take longer time, but it will work with no issues whatsoever. So that's the first question. The second question is, how does the slow changing dimension type implementation work? Now, let me just slightly go back on this question and tell you that I didn't mention that explicitly. I should have mentioned that, but slow changing dimensions is the term that primarily is used with the warehouse dimensional models, or we may know them as the star schemas, right? So now slow changing dimensions don't exist, therefore they just simply don't exist in bronze or silver layer, because bronze and silver layer, they're not dimensional models, they're entities. What that means is that you have, say, for example, you have a customer and they have an address, for example, shipping or billing. And such an entity address, it can be in the dimensional model as no slow changing dimension because the customer is the same, but they may have moved their warehouse to a different place where they receive their shippings, or they may have changed the office address where they receive their billings, right? Now, that would be a slow changing dimension for that specific entity, but it will not be a slow changing dimension in the table of the addresses, because once we modify it, it will be the only value, right? The only way to track changing dimensions is to track them in the dimensional model that incorporates the structure for slow changing dimensions. We didn't explore it here because we didn't create a fully dimensional model, but the target layer in the medallion architecture for the slow changing dimension will be the gold layer, not the silver, the gold layer. That's where we will have our slow changing dimensions. Additionally, this, so because you can implement your dimensional modeling using MLVs, but MLV's declaration, it does not have any merge in it whatsoever at all, right? Because it's just a declaration of the structure. It will have the joins in it. So for the, say, if we create a dimension of a customer that will incorporate their own address, last known or multiple, one of them will be active, right? So we'll have the additional records for the customer entity that will represent each and every instance of the address that was changed in the reporting time that we keep in our warehouse. In that case, when we update the materialized lake view for the gold layer, behind the scene, the Spark SQL that is generated for the refresh, we don't do it manually. That's the magic of the materialized lake views. We only declare the structure, but the update is done automatically for us. The merge query will be generated. It will execute insert or update based on the schema that we define in our materialized lake view. To support incremental changes, because imagine that you have 100 million records, right? You don't want to full refresh every single time. It will be too time consuming. So materialized lake views, they support already out of the box incremental refresh, which is based on enabling the change data feed on the Delta tables. It's an operation that needs to be incorporated into the syntax of creating the materialized lake view. There is a documentation on Microsoft Learn for Fabric related to materialized lake views that explains how to enable this particular feature, incremental update on materialized lake views. My personal opinion is that at this point, I would not want to implement a very complex and very large warehouse in Fabric using materialized lake views for one simple reason, because they have a limitation on executing the incremental refresh based on the SQL syntax that was used for defining. It's documented again for MLVs on Microsoft Learn. You can go there and check it out, but there's a list of SQL constructs that are not supported for incremental refresh at this point. That's a limitation.
Okay, I think that's the last question. So while you were answering and you said there's a documentation, I went online,
Yep.
searched, and I've pasted it in the chat. So I think you've done justice to all the questions. And luckily for those who feel they want to rewatch the video, even for me, the session, I'm going to make sure I referenced it, sometime in future when I need to do something that I want to again see some of what you've done and just be sure that I am replicating what you've explained. So thank you to everyone who has stayed till now. And again, thanks a lot, Alexander, for the session. And this QR code is your way to connect with Alexander on LinkedIn. If you just point your phone to it, it's going to take you to his LinkedIn profile and you can connect with him so you can always be in the know and see when he's got sessions or that things where you can participate. I know he likes to present at different places, so it might be one of your ways to get in on some interesting events, tech events and sessions, especially here in Toronto. I'm going to end the session now so that we let Alexander go rest too, and you too, get to rest and we meet next month. I've put in the chat the link for the session for next month. Make sure you join the main community so that you're always notified of sessions. We actually have a lot lined up for the rest of the year. We have about 28 sessions already submitted that I'm working through how to schedule them so that we don't have similar sessions back to back. So, this year is going to be a good one. So thank you, everyone. I don't know if Alexander wants to mention anything before I end the session.
I just wanted to mention that next one that Michael already planned, and I'm also honored to present in March. It will be a very interesting one because we will be talking about the new feature in Fabric that's called Fabric IQ.
Yeah,
and so we will be dealing with the AI agents there as well. That's a little bit of a spoiler alert or a sneak peek.
Thanks. Let me, follow up on that with pasting the abstract and things that can help you see what the session is about. And the link is also in the chat. So I would say, sign up. Worst case, if you're not able to make it, you get notified about the recording. So there's no downside to signing up without having to overthink, oh, am I free that day or not? So thank you, everyone, and special thanks to Alexander for the deep knowledge share, the patience to answer our questions, walk us through demo, even show us some troubleshooting steps. And that's the thing I like a lot about your sessions is the fact that you take the theory, make sure we have the basics covered, and then you take us into the demo, and we're able to see how you apply all of these on real world projects. So thank you very much, and I will say have a nice evening and a great week ahead. And we'll definitely meet on this series next month. I hope we see everybody who joined today also next month. Thank you all. Have a good evening. Bye. Getting the meeting now.